Hello, my name's Trey. I'm with the Double E Zone. Today's circuit is going to be dealing with modeling total resistance. Get started here. We need to see we have a 120 volt source. We have a load that's 3.05 ohms, and it is a distance 3 miles away. In the past, when we've dealt with circuits, when our conductive material that's connecting everything is short, we just assume zero resistance. But in this case, since we have such a great distance, we're going to need to model that distance using these conversion ratios. The first one here is giving us ohms in terms of feet, and the second is feet in terms of miles. We're going to use that as part of our calculations here in just a second. So let's go ahead and get moving on that. Move this out of the way. And first, we got 3 miles of material. We need to put that in terms of feet because of this conversion ratio is ohms to feet, so we need to have feet. So let's go ahead and do those calculations. 3 miles times 5,280 feet over a mile. What's that going to give us? Well, first note that miles cancel, and that just leaves us our answer in terms of feet. That's going to be 15,840 feet. Now, we're not done yet. We need that feet to be changed into ohms, and so what we need to do is use our conversion ratio up top here. We'll say that 15,840 feet times 0.405 ohms over 1,000 feet. That is equal to, and we need to note feet are going away, and this is going to be left in terms of ohms, and that's going to be 6.4152 ohms. Now, something we should see from this is that the distance to the load and the distance back from the load can now be thought of as a resistor that is 6.4152 ohms, top and bottom. So our total resistance for this circuit will be given as our load, 3.05 ohms, plus 2 times 6.4152, or 15.8804 ohms. So that concludes the video. It's fairly straightforward for these calculations. If you have any comments, just leave them below, and again, thank you for listening.